வணக்கம். Polycarbonate resistors. Such a polycarbonate capacitors. Polycarbonate is a polyester of carbonic acid bisphenols. It combines good physical properties with a lower dissipation factor than polyester. The metallized polycarbonate film is rolled and scaled in a metal case with epoxy resin. It is insulated with a polyester sleeve as it does not have as much as available oxygen. Its self-healing properties are not quite as good as for polyester. It has a higher insulation resistance. It can operate at temperature as high as 125 degrees Celsius. Polycarbonate allows the manufacture of close tolerance, typically plus or minus 1%, stable, small physical size, long life capacitors, and is mainly used for DC applications. Though it can also be used for AC applications. They are available in the range of 0.1 to 10 microfarad. They are not capable of withstanding higher voltages. A comparison chart of some of the main characteristics of the three types of plastic dielectric capacitors. Mica capacitor. The dielectric used in mica capacitor is muscovite or white mica, ruby or rose colored mica, and amber mica. It has a dielectric constant between 3 and 8 and dielectric strength of 600 to 1500 volt per miles. Volt per mil. Its breakdown voltage widely varies from 500 volt to 20 kilovolt. It has low losses and power factor varies depending on the dryness from 0.01 to 2% and can respond to very high frequencies. It can withstand the temperatures up to 400 degrees Celsius. It has a better temperature. When the shaft is rotated, the effective area that exists between rotor and stator plate varies, thereby varying the capacitance. The shape of the plates determines the manner in which capacitance varies with the shaft rotation. The variation will be linear if the moving plates are semicircular. For tuning purposes, a uniform scale for frequency is required. A simple relation between the capacitance and angular rotation is given by 1 by C is equal to A theta plus B the whole square, where C is the capacitance, A and B are constants, and theta is the angular rotation. The capacitance value for air variable capacitors range from a few picofarad to up to 500 picofarad with a maximum voltage rating of 9 kilovolt. For high operating voltages up to 60 kilovolt, a vacuum variable capacitor is used. Miniature type of variable capacitors uses thin plastic film dielectrics between the plates. The entire assembly is enclosed in a molded transparent plastic case to prevent entry of dust. These capacitors are typically low voltage units and they have a limited type dissipation factor. An ideal capacitor, when discharged, gives up all the electrical energy that was supplied to it in charging, but practical capacitors dissipate some of the energy delivered to them. That is, they suffer from losses due to dielectric losses, particularly at a higher frequency. Insulation or leakage resistance of the leads and plates. The insulation resistance and dielectric strength are lower if the capacitor is operated at a high temperature, high voltage, and and humidity. The leakage losses increases with the frequency, applied voltage, and temperature. The voltage rating of capacitors has to be reduced if operated at a high temperature and humidity condition. The power factor of a capacity expresses the ratio of the power dissipated per cycle to the power stored per cycle In a capacitor, the power factor is the ratio of the equivalent series resistance to the total impedance of the capacitor. That is, PF equal to RS divided by Z is equal to R divided by square root of RS square plus XC square. The dissipation factor dissipation factor of a capacitor is the ratio of the equivalent series resistance to the capacitive reactance. That is, DF is equal to RS divided by XC. For low losses, that is, RS is less than XC, the power factor is equal to dissipation factor. The equivalent series resistance is due to capacitor plates with leads and insulation or leakage resistance. For an ideal capacitor, R is equal to 0 and hence PF equal to 0. Due to the losses, a practical capacitor has a non-zero power factor. For a practical capacitor, the power factor angle phi is not 90 degree but slightly differs given by 90 degree minus theta. This angle is called as loss angle of a capacitor and tan theta is usually specified as the dissipation factor. Dissipation factor is another parameter used to describe the quality of a capacitor. The reciprocal of the dissipation factor can be considered as the Q of the capacitor and is the ratio of the capacitor reactance to the equivalent series resistance. Q is equal to 1 by dF is equal to Xc divided by Rs is equal to 1 by omega C into Rsa. It's by tan pi. Tan 90 degree minus pi is equal to cot theta. Tan 90 degree minus theta is equal to cot theta is equal to 1 by tan theta. Thus, higher Q means better quality of capacitor. Connecting capacitors. Capacitors in parallel. In this figure shows that n capacitors are connected in parallel. Here as the effective area of the plate increases, the total equivalent capacitance of the parallel circuit CTP increases with the plate area. Hence, CTP is equal to the sum of the individual capacitances. CTP is equal to C1 plus C2 plus up to Cn. When all the capacitors are equal, then CTP is equal to NC. The relationship for CTP is similar to that of resistors in series, capacitors in series. It shows N capacitors connected in series. Here as the separation of the outer plates of the combination increases, the total equivalent capacitance of the series circuit CTS will be less than the smallest capacitance of the individual capacitors. The value of CTS can be calculated by 1 by CTS is equal to 1 by C1 plus 1 by C2 plus up to 1 by Cn. The relationship for CTS is similar to that for resistors in parallel. Considering two capacitors C1 and C2 connected in series, the total equivalent capacitance of the series circuit is equal to the product divided by the sum. That is, CT is equal to C1 into C2 divided by C1 plus C2. When equal valued capacitors are connected in series, then CT is equal to C divided by N. Characteristics and applications of various types of capacitors are summarized in the table. In this table, characteristics and applications of capacitors are inductors.